Good morning, everybody. So, today I'm very excited. It's been a while since I streamed. I had quite some things going on, but yeah, today will be a special stream because I don't know how much code we will write. So usually we write code here, right? But today I want to go through the Angular Signals RFC. So we have seen that recently, I mean, we already had like a meeting because where we GDs could take a look at this, but this is now public, basically. Yeah, we can now all see what we already had like seen previously. So Angular Signals are coming. The RFC is now public. And yeah, there is more to it than just signals, right? So it's probably the biggest change in Angular's recent history. Feels like this is really going to shape the future of Angular. So yeah, also today the Angular team has a live stream where they will be on and you can discuss these signals, the RFC with them, which is pretty cool. So yeah, let's see. Okay, the RFC basically is split into 4 parts. So yeah, here are the goals of the RFC, but the interesting thing is that we have 4 parts. The first one is signals for Angular reactivity, like why do we need signals? What's the benefit of having signals? Then we have the signals APIs, which is discussed here. Then we have signal-based components, which is something that is very interesting. So we will get signal components, but we will see that in a minute. Then observable and signals interoperability. That's basically something that we've already done on stream, is like converting signals to observables or observables back to signals. So yeah. So let's see. Let's probably start with signals for Angular, and then we will see how far we go. And based on that, yeah, I don't know, I have like around 2 hours, so let's see how far we can go. Okay, so here, why a new reactive primitive, right? Because we already have reactivity in Angular in terms of we have RxJS, but this is still something different. So this is really, Signals is a reactive primitive, like a built-in type, a reactive built-in type. So in a model-driven web application, one of the main jobs of the framework is synchronizing changes to the application's data model and the UI. We refer to this mechanism as reactivity, and every modern web framework has its own reactivity system, yeah. There are some frameworks like Solid or Svelte or even Quick that already have signals or a reactive type built into it. So today, Angular's reactivity relies on the Zone.js library, yes. Reactivity with Zone.js has both unique benefits and unique challenges, which are discussed in more detail below. So why not continue with Zone.js? I think there are multiple arguments for it, but let's first continue. Crucially, Zone.js does not provide fine-grained information about changes in the model yet, because Zone.js, if you think about it, that has actually nothing to do with change detection, right? Because it just tells Angular, hey, Angular, something changed. Go figure out what changed. It's not like Zone.js tells you here was a specific change. It just tells you something changed. Go figure out yourself what changed. Yeah, Soncha is only capable of notifying us when something might have happened in the application exactly and can give no information about what happened or what has changed. In order to achieve our main goals, the top-level RFC goals, we need to introduce a new reactivity model. Yeah. This means adding a new primitive to the framework which can provide fine-grained information about model changes. A major design goal of Angular Signals is to make the integration of these two reactivity models as seamless and straightforward as possible. So you will be able to mix change detection with zone and signals, actually. So developers can concentrate on shipping features, yeah, instead of reasoning about how change detection is going to work in their application. So that sounds good. Yeah, so the Angular team was thinking hard about how they want to have a new reactivity primitive. Sorry, it's still morning. So yeah, they were thinking about how to bring a reactive primitive to the framework. And basically the criteria for this is it must be able to notify Angular about model changes, yeah, affecting individual components. So that's cool, then you can have change detection per component and not per application. It must provide synchronous access to the model, yeah, because template bindings must always have a current value. Right, that's also with the async pipe now. The async pipe initially emits null, so there always has to be a value. Reading values must be side effect free. Okay. It must be glitch free. Reading values should never return an inconsistent state. So that's something that you can have with RxJS. You can have inconsistent state here. Depends on when you do, for example, something with combined latest, it can be that you have an inconsistent state. Dependency tracking should be ergonomic. So this will be the first discussion point. Is there anything else that we should consider? I don't think so. I think those are the most important things. So they experimented with a number of alternatives, improving Zone.js, which I personally think is the wrong approach. I don't think this is the way to go. Set state style APIs, that maybe Signals, of course. RxJS, nah. Compiler-based reactivity proxies. So yeah, my personal favorite would also be Signals. But let's see why they came to this. So during our research, one reactivity model stood out as clearly meeting our requirements while offering a very natural developer experience, Signals. Signals are not a new idea in the framework space. Preact, Solid, and Vue all employ some versions of this concept to great success. So what is this primitive? So a signal is a wrapper around a value which is capable of notifying interested consumers when the value changes. It sounds a lot like from the mental model, it's a lot like a behavior subject actually. So there are different kinds of signals. Some signals can have their value directly updated via mutation API. In our implementation, these are known as writable signals. Updates to the model are always done by changing one or more writable signals. Okay, because reading a signal is done through a getter rather than accessing a plain variable or value, signals are able to keep track of where they're being read. And because mutations are always done with the mutation API, signals can know when they mutated and inform previous readers about the change. So basically, internally, they probably have some list of consumers, and whenever you write to it, they will notify those consumers. So a computed signal has a value which cannot be changed directly, but which is derived from other values of other signals, yes. We've already seen on previous stream how computed signals behave, what a computed signal is. So basically it's like you have a computed signal is derived from other signals. And whenever another signal that you use inside this computation function changes, you will basically get like a new value in your computed signal. Yeah. A good example is a counter numeric value and the Boolean is even flag which tracks whether the counter is even. We could model the counter as a writable signal and increment or decrement it directly. Is even is best modeled as a computed signal. So basically whenever our counter then changes, the computed signal, or the is even, yeah, which is the computed signal, will update. Then we have effects. So with effects you can basically run some function whenever a signal changes. Automatic. A cornerstone of our signal system design is that when computed signals and effects run, they keep track of which signals were read as part of the computation or effect function. Knowing the dependencies allows the signal system to rerun the computation or effect function automatically whenever any signal dependencies change. Makes sense. So why is this a good fit for Angular? So with this change, the framework can track which signals are accessed in a given template. So with that we get fine-grained information, so that's an important thing here, fine-grained information, about which components are affected by a given change to the model. That's cool. So with that we have Angular knows, like imagine now change detection works in a way that Zone.js monkey patches all the async APIs like set timeout, like click handlers and so on. And then whenever such a async API is used or an async event occurs, Zone.js just tells Angular, hey Angular, something changed, please go from the root and go down and check all, basically figure out what's changed. And Angular does this with dirty checking, so he checks what's currently the DOM and what is in your model and is there something different. And with signals, basically you get fine-grained information, so you know, okay, my customer component changed. And then you only have to go and update that and not update the whole application. So signals allow synchronous access to their values. That's good. Reading signals can trigger side effects. Like with side effect, yeah, reading doesn't really trigger it. So, because effects are run when you update them, right? Not when you read a signal. Modern signals implementations are glitch-free and don't expose, inconsistent state. Signal implementations can track dependencies automatically, can be used anywhere, not just in components, which plays well with Angular's dependency injection system. So, sounds pretty good. Additionally, we see a number. By the way, I hope the text is big enough. Let me see if I can even make it one bigger. Maybe that's better. Yeah. Computed signals can be lazy and recompute intermediate values on demand. There are relatively few concepts for developers to learn. I agree with that. I think it's very easy to teach signals. So they are easily composed with other reactivity systems, including RxJS and Angular's current zone-based reactivity. Yeah. So, because I think zone-based reactivity is something that you have to decide in the beginning, because that's something you get it's like an application-wide decision. It's not like you can say this component runs with zone, this runs with signal. I think you have to say my whole app runs with zone-based reactivity, and then I have some signal components in it. I think you will only get full fine-grained change detection when you go full signal components. But yeah, of all the alternatives, our conclusion is that signals are the best fit for Angular and will allow us to meet our overall goals. So how will Angular make us use of this new reactive primitive? Signals will affect many areas of the framework, especially including data flow and model, the change detection process, component life cycle. I think we will get some new life cycles. Manprolex, hello, how are you doing? Reactive values produced by the framework. Yeah, we will also get some different syntax for inputs. It's something we will see in the other RFCs. Yeah, so in this section we'll dig how signals will fit into Angular's component model. Zones are here for the foreseeable future. Yeah, I also think so. I don't think that it's realistic that we now get signals and everything else basically, and we drop zone immediately. I don't see that. I think we get signals, and you can start with a signal-based API in the future. Signal-based API with signal-based components, and if you have like full signal-based components, then you can get rid of zone. But I don't think for existing application that you can just now migrate Angular 16 and you update and then you go without zone. That's not the case. I have an assignment due for CISV. What is CISV? And now I'm stuck. We're introducing a new type of signal-based component which uses signal for its reactivity. Ah, computer science. Okay, computer science course. Okay, what kind of topic or where are you stuck? We're introducing a new type which uses signals for reactivity and rendering. Both the new signals component and the existing zone-based components will be able to use and interact with each other in the same application. Just basic. Okay. Just making basic HTML web page. Okay, so you have to deliver it in 1 hour, I guess. And you're pretty late, actually. See, it's applying to one web page, but not another both. Yeah, next time I will do it sooner. Okay, so basically, like the CSS pages you include on the top with the style tags, right? And I don't know how your project is structured, if you use any kind of framework or just basic HTML, but you should be able to just import it on the top with the styles tag. So I would check where you import the CSS. Should probably only be in the index HTML. Or if you want to have a specific file, yeah, add link rel. Yeah, that looks actually pretty okay. That looks pretty okay, yeah. And now I don't know if you have like multiple pages. Same in the file, it works. Yeah, if you have multiple pages and you only want to include it in one, I guess you should only include the CSS there. Using components as the boundary between reactivity will allow application developers to gradually opt in Signaler and allow library authors to convert their libraries. Yeah, backwards compatible way. That's always the way Angular does it. Yeah, this is also some important note. So we only speak about components here, but everything works also for directives. So local change detection. So one significant new capability is that signal-based components will have is local change detection. Unlike Zone.js, signals give fine-grained information. Yeah, that's something we already talked about. Yeah, about which parts of the model have changed. Signal-based components do not participate in the global change detection. Okay, that's interesting. Instead, Angular understands which signals are used in different parts of the component's template and only synchronizes that component with the DOM when a signal changes, which is great. So this is the golden rule of a signal components. Change detection for a component will be scheduled when and only when a signal read in the template notifies Angular that it has changed. So this is something we should keep in mind. The golden rule of signal components. Maybe this is something we should tweet. Yeah, can I? Maybe let's do it like this. So let's do it like this, yeah. In fact, in our current design, this change detection will happen independently for each view within a component. So MenPro, Alex, I hope you found the solution for your issue. I don't know. So as you said, like the CSS is probably applied to multiple elements. I would generally always use classes when you use CS to avoid like style clashes. Then you could avoid it even if the CSS is loaded once, if you use specific classes for the elements. Yeah, and I wish you the best of luck for your assignment. So, Angular's view concept. Views in Angular are static fragments of templates, sets of known UI elements, directives, and child components. Views are composed together to create templates that can express conditional or repeated sections of UI. So, for example, this one is a single view, but I guess if you use something like ngIf, ngContainer, ngSwitch, all those things are probably like separated views. Whereas this template has two views. Here we go. The outer DOM with who and what, and an embedded view, which is conditionally shown, which contains Y. So this is the embedded view, because we are using ngIf here. Each branch of an ngIf, ngSwitch case, or each row of an ng4 are examples of independent views in Angular. Yeah. So basically then, even those are views. So probably when you use a signal inside here, Angular knows that only this view updated. So he probably will only check this and not the whole thing. That's what I guess. The choice of per view change detection is an important one, as there's an entire spectrum of granularity which we could track changes to the model. Yeah, so you can go per view, you can go per component basically, or you could even go like even more fine-grained, but I don't know, there are probably trade-offs, I would say. So entire application, that's basically what's happening today with Zone.js, unless you do the on-push optimization. Component tree, subtrees, individual component and its children. So that's basically, I think that's a bit what's happening also with on-push. Individual component, checking a component, including all of its views, but not its children. View, checking each view individually. DOM element, updating all the bindings for each DOM element individually. Text node elements, Solid.js works at this level, so that's then like probably the most or pretty fine grade. Binding, updating each DOM binding individually. Okay, that's probably the most fine grade. But this is already pretty fine grade, right? So I guess we will get here, like the third deepest level. So why check per view and not update individual bindings? Yeah, that's a good question. So I'm curious of the trade-offs here. Would that not be the faster, more efficient? The trade-offs here are not so clear-cut. And while we are interested in exploring designs with more granular updates in the future, there are few reasons why we believe per view checking is the best option. Okay. So dependency tracking has overhead because you probably have to have some sort of graph internally. Yeah, setting up the dependency graph is not free. Yeah. Our signal library is fast, but the more granular the tracking, the more nodes in the graph need to be allocated and book kept. Yeah, that makes sense. I think that's a valid trade-off. This not only takes time, but consumes memory. We have to weigh this cost against the potential benefits of increased granularity. Yeah. Checking individual views delivers most of the benefit already. Views are typically small fragments, so yeah, even if views are then ngIf, ngSwitch case, all those kind of things are individual views. So I think that's already pretty granular. The cost to evaluate and change detect a small set of bindings is already very low. Yeah. The most expensive components to process with change detection are often those with large, repeated, highly dynamic structures, such as data tables with hundreds or thousands of rows. Such components are naturally already broken down into many individual views, yes? So it's not like one component that has a lot of things is then one view. That's not the case. For each row is at least one view. With view-based change detection and properly structured model, signals can already be used to drive updates only to one row of the table without needing to process other unchanged rows. Yeah. This is probably also an important thing, right? I think the Angular team could do much more in terms of going forward and more radical changes if they would go with an approach like, here is Angular 16, migrate to it and nothing else works. But since they always try, and I think this is a great approach, and I know from my experience, like working with like providing a library for like 80-90 spas, being backwards compatible is such a hard task. Like it limits you often. So I think they do like an amazing job of always being backwards compatible, because that limits you hardly in like going forward. It's not so easy to be always backwards compatible. But yeah, they always somehow find a way, and I really appreciate and think that's, yeah, kudos to the Angular team. So the operation of running change detection against the view is already the main primitive on which the existing zone-based whole application change detection system is built. Yeah. Using the same granularity for signals makes the interoperability, I have so much trouble pronouncing this word, interoperability, story much more straightforward and allows the two reactivity models to share most of their underlying. Yeah. So basically, I think the trade-off to go, I think it's a valid trade-off, because this view-based change detection is already pretty fine granular. And yeah, you could go on DOM element or binding, but binding probably, I mean, Solid also does it on DOM element. So binding probably really is like the trade-off that the graph is just too big, I guess. And it's too much you have to do for the graph. DOM element probably could work, but since we already have Vue and Angular, as we've seen, if you have this huge data table, then you have multiple views. I think this is already pretty good, especially if you think about being backwards compatible. I think that's a great trade-off. So inputs are signals. In signal-based components, inputs will be signals. Also, heads up, we will later see this I think it's in the RFC 2, but you will get like a new way of writing inputs. So today what we do is add input, but in the future we will write it differently. We will see that in the next RFC. Sorry. This choice is directly aimed at the goal of having a clear and unified model for how data flows through an application. Signal-based inputs have a major impact on data flow because they work as computed signals and not change detected expressions. Yeah, so let's see how, to understand the difference in how signal-based inputs work, it's useful to consider in more detail. So in a zone-based today, what we would have a homepage component, and this homepage component uses a user profile, and inside there we have a user data and we pass in auth service logged in user.data. Suppose the logged in user changes, Zone.js will notice something happened but doesn't know what specifically changed, and will trigger change detection for the whole application. Yeah. So usually logged in user changes based on a HTTP request or on something like this. Then Zone.js kicks in and tells, hey Angular, something changed. Change detection will be triggered, and it will then process the homepage component and re-evaluate the binding of user data. The expression author is logged in user.data. It will set the user profile component user data field to the new value before descending into the user profile component and evaluating its template. Yeah. So that's how it works today. So it basically updates during change detection. If home component and user profile component were signal-based components, the user data input would function very differently. Of course, the bindings would have to use signal for the logged in user. So you can see that we call here something. So this is basically then a signal, and .data is then just the data of the user, but the logged in user is basically a signal. So this is the signal. When homepage component is first created and it's creating its user profile component child, Angular will create a computed signal for the user data binding expressions. So this internally they will create a computed signal, and then whenever this change, of course, this will be recomputed. This derived signal is then provided as the value for the, this has huge implications. Yeah, so exactly. Signal inputs resolve before change detection. So that's an important thing. Because the other one happens during change detection, right? Because you just tell him something changed, and then during change detection you go through and then you update the value. So I guess when we have this, we will probably, let me think. I guess we will never have the case of the most famous Angular error expression changed after it has been checked or something like that. So I guess we will never enter that case. But that's just thinking out loud, I'm not sure. I think so. Updates to the user, because this change originates when we have change detection. So basically you go through, you check something, and then you go further, and then later it's updated. So then the value is out of sync. Updates to the user data. Yeah, this is the major difference from some-based. With Signals, the model-to-model synchronization resolves before Angular starts any UI synchronization. This eliminates an entire category of data flow. Yeah, exactly. So expression changed after it has been checked errors are no longer a risk because the model is fully synchronized before it gets checked. Data can flow independently of the UI hierarchy instead of being forced to only flow from parent to child. Yeah, so there's no need for the set timeout or promise resolve or other tricks. I don't know if you ever had to do this, but we had some cases where we were projecting some stuff. So let's say you write a custom checkbox, you write a checkbox component, and inside there you write your checkbox items or something, or a radio button is a good example. So you have the group, the radio button group, and the radio button items. And if you project those and you want to update the values somehow, you have to do that during a lifecycle hook. And then sometimes you need to do set timeout so that it runs in the next tick, so that it properly gets picked up by change detection, and so on. There are some tricks that you sometimes have to do. So usually you shouldn't do this, right? Usually you shouldn't do this. But there are some cases where it's really needed, and you can also go and debug the Angular material source code, and you will find some of those set timeouts in there. Input bindings don't trigger local change detection in the binder because user data's binding provided as a computed signal. None of the views in the home page component depend on its value. Yeah, per the golden rule, so nothing will change because it's not red. Input bindings don't automatically trigger local change detection in the receiver, yes, just because only because the user profile component receives the user data, it doesn't mean that any change detection will run, and unless, or I think the way I understood it, as long as it's not read in a view. Per the golden rule, user profile component will only be change detected if it reads the user data input signal somewhere in its template. In other words, inputs which aren't actually used in a template don't trigger any change detection. Yes, exactly. When logged in user changes, homepage component doesn't need to change detect any views. That's because it never actually reads the logged in user value for itself. It only forwards it as computation to its child component. So I guess what you could do then inside the child component, so you could probably use an effect to run some. Let's say you want to react, you want to do something once this input changes. So similar to ng-on changes. So generally I think ng-on changes will disappear and you will replace it with effect. Like for signal-based components. Queries are signals like inputs, view, and child queries are an example of the framework producing a reactive value which represents some aspect of the component models. In signal-based components, queries will also be exposed to signals. This allows components to naturally react to queries changing via computed properties or effects. Just like with input, yeah. So now mixing signal and zone components. So it's possible to freely mix signal and non-signal components in the same application, which is great, as long as the golden rule of signal components is observed. Change detection should function correctly even across these boundaries. When a signal component provides an input binding to a non-signal component, so we would have a signal component and it has an input binding to a non-signal component. Signal semantics are used to detect when the binding changes and set the input of the non-signal component, mark it for check if necessary, and run ng-on changes if needed as well. When a non-signal component binds to the input of a signal component, a similar conversion happens. During change detection of the non-signal component, the binding is evaluated, and if the value has changed, the input signal passed to the child component is updated. So basically, this says that we can use non-signal components together with signal components, and they will basically call the correct lifecycle hooks, and vice versa. Non-signal API issues. Sometimes directives expose APIs for their consumers by a local reference for the DI system. Okay, for example, engine model exposes its current value as a public property. So when you do something like this, I've never done this, but I know that this works, so you can get a reference to engine model and then you can use its value. But if you would move this up, you probably get an error. So you basically have to use it in the correct order. Such APIs may be problematic in signal components, since in value isn't the signal and can be used to trigger change detection, even though it changes as the user types. Note that in zone-based components, relying on data from a child like this is hugely problematic anyways. Yeah. If the reflection of the current value is moved above the input, so if you would turn this above the input, you get the famous expression changed after it has been checked error. Because first the P is compiled and then in that value is basically undefined, and later you go and it's set. For Angular author directives, we will revisit their APIs and adapt them. We would expect community libraries to eventually do the same, but this process will take time. Yeah. So there is a lot that also comes for the Angular community with this approach, supporting those kind of things. Zoneless Angular. With Signals, it will be possible to build an Angular application without Zone.js, rather than relying on zones for change detection to function. But this probably only works if you have Signal only, right? It will not work that you do edge update and you get basically you can drop Zone.js. That's not the case. Yeah, signal-only application will schedule change detection for individual views directly, like via request animation frame or some other views browser primitive. In such an application, it would be an error to attempt to use a zone-based component. Okay. Will Signals lead to Zone.js being optional? Yes, this is one of the driving motivations that led the team to Signals. If you write an application exclusively, this is important, exclusively composed of signal-based. So it's not like I write my app and easily can drop out of zone. So you need to revisit the whole app if you really want to drop out of zone, or just start with a new one where you go exclusively signal-based. So yeah, is Zone.js zone-based change detection deprecated or removed? No. Zone-based change detection will remain supported for the foreseeable futures. Components that depend on Zone.js and Signals can be freely mixed in one application, yeah. An application would have to fully track its model in Signals to completely remove dependency on Zone.js. Or probably you still get access to the change detector ref and you would need to trigger change detection manually. So are we going to have another change detection strategy? I don't believe so, because signal components, the way I've seen it is like you use signal true in the component declarator and it has like broader side effects than just change detection. So therefore I don't think so, but many applications and terms recommend the on-push change detection strategy to improve performance. Signal-based components have on-push on steroids baked in. In the design proposed here, only components that read and update signals will have to be change detected. None of its parents and none of its children. Yeah. One and only one component that needs to display change data. Signal-based components have all the benefits of the on-push strategy and more, without any of its drawbacks by default. Okay, so once you use signal through, you are basically on-push. In this sense, we actually move the very concept of change detection strategy. Yeah, I can imagine that. So if you go like signal-based, probably this, I don't know if they will make some lint routes, but this change detection strategy, you don't have to care about it. Yeah, state management. So yeah, I think like if you look at signals at first sight, it looks like it provides a lot. It provides a lot of NGRX functionality. It has effects, it has setters, it has mutations, all these kind of things. You have computed signal, which is similar to selectors where you calculate derived state. But I don't know if you have seen that stream, I tried to make to replace NGRX with signals. It doesn't really work that well because you still need structure, you still need a lot of things that NGRX gives you. So yeah, it will not be, signals will not replace like state management libraries. Yeah, you see this kind of stuff, it will not replace. And also they say we have no plans that developing a first-party state management solution in Angular itself. So yeah, there are a couple of requests, RFCs for NGRX. That's maybe something for another video. And NGXS. I don't know if I would ever use NGXS, because I think also if you check, I don't know how up to date it is. NGXS store. So now they are on version 3.8. Last time I checked, they were not compatible with the latest Angular version, which seems like it's not fully maintained compared to NGRX. Like NGRX is always up to date with the latest. But this is last week's release. Yeah, I don't know. I just think like NGRX is kind of like the default there. But that's my opinion. So this is also an interesting one. Why not use RxJS as the reactive primitive? So basically, yeah, we could read through everything, but I think the headlines explain it very well. So observables are naturally asynchronous. You don't know if an observable is sync or async. You just assume it's async. And then I think this makes stuff way harder, especially because in a template you need like an initial value. Yeah, in Angular templates, bindings always have a current value, so this probably makes it way harder. Then also it's a third-party library, you don't get like the full control. It's not side effect free, that's true. So if you would have this, so let's say user data is a observable, so basically it's a backend request. User data is a observable that does basically this, HTTP client get. So whenever you subscribe to this, you perform a backend request. So if you would do this, you would do 2 backend requests. And usually what we do is we wrap this with an ng container, ng if data as user data, and then we just unwrap it here. So that's usually what we do there, but it's not side effect free. Or you could also use share or share replay, that would also work. This one is also interesting, it's not glitch free. So what they mean by that, they have like this great example here where they have a counter, which is a behavior subject, and then an isEven. IsEven basically just calculates if the stream that comes through this counter stream, if it's even or not, and then you do combined latest. And then you have the counter stream with the latest of is even, which is 0, which is then basically resolved to true. And then what happens in the next tick is like when you get 1 as the counter, but the latest here is then still resolving to is even, which is true. And then you get is even odd. So you see, then you get basically an inconsistent or a wrong state, like 1 is even. So in these kind of scenarios, you will have like some, that's what they mean when they call about glitch free. Yeah, because of these incompatibilities with using observables for template rendering, we decided against using them as the basis of Angular's reactivity. We believe their strength lies in orchestrating complex asynchronous operations. Yeah. I think that's good. This is an interesting one. What about Angular's API that currently use RxJS, right? We have a lot of APIs that use RxJS, like HTTP client, event emitter, forms, router, all those kind of things. RxJS is kind of baked in. So the general plan is to review Angular API surface and selectively convert RxJS usage or add signals when appropriate. This will not be an automatic conversion. Yeah. As RxJS based APIs might represent two distinct concepts. Value changing over time. Yeah, those are perfect candidates for signals. Form validation, status, or router params are great examples. Stream of events. Those conceptually don't match signals and would not be converted. HTTP client and event emitter are perfect examples of that should not be expressed as signals. Okay. I'm still thinking stream of events, because an HTTP client, an HTTP request, is it really a stream of events? I mean, you fire, you get one. It's more like, it's really like a promise actually. You get something and then you're done. You fire once, unless you do like something with a socket or something. But the general HTTP client, like a normal HTTP request, is not. Is it really a stream of events? Not so sure, but event emitter, yes, definitely. In any case, we will come back to the API surface review after the initial signals rollout. So yeah, they will roll out the initial signals and then any changes will be done in a backward compatible way. So signals would be reactive primitive, deeply integrated in the framework, and thus a Go solution for state synchronization needs. This is the first reactive tool that people should be reaching out for. Okay. Yeah, RxJS shines when it comes to orchestrating complex asynchronous operations. Observables power and flexibility comes at a certain cost, mostly related to the learning curve. Yeah, so we see use cases where RxJS shines. So last time what I did on stream was also, I think this is a perfect use case where RxJS shines. Whoa, this is super big, but yeah, we did this, probably most of you have seen it. I also did a video on this, where we have the GitHub user search, and there basically what you want to do is you want to have RxJS. So how would you do this with Signal? If you have an input and you fire off some requests based on that input, based on the type, basically when you type something, and you want to debounce time and distinct until change and filter and switch map, all those kind of things, this is where RxJS shines. When you fire off a request and you only want to fire off if an event occurs within 500 milliseconds, only if the thing changed, you want to filter it, and then also you want to cancel outgoing requests and stuff like that. For those cases, I think RxJS is, there's nothing better than RxJS. But those are the rare cases, right? And the cool thing is we will get this to observable from observable. That's also in the RFC, which allows us to convert to signals or from signals, which is great. Yeah. Yeah, so why not evolve Zone.js? So basically, yeah, Zone.js approach isn't scalable because, right, Zone.js, what it does, it monkey patches, set timeout, like all event listeners, all these async APIs, but the browser evolves at the same time. So for example, we got async await now natively supported, and then, yeah, so here it's all of that is written here. I'm just putting it with my words. So basically, whenever something evolves in the browser, you have to adjust Zone.js. So you basically, every time the browser introduces some new async API, Zone.js need to be adjusted because it also needs to monkey patch that new API. So that's not really scalable. So I guess that's a lot of work on the Angular side. Yeah, Zone is a root cause of many common pain points. In looking back at 7 years of Angular history and feedback, we've identified Zone.js a common root cause behind many developer experience or performance challenges. Yeah, the infamous expression changed after it has been checked out is often the result of violating Angular's assumption of how data will flow in your application. Yeah, Angular assumes that your data will flow from top to bottom along with a view hierarchy. This assumption is rooted in how Zone.js separates model updates from UI reconciliation, resulting in the potential for unsafe model updates. Yeah, another issue is that Zone.js can easily overreact to activity in application, resulting in many unnecessary change detection. So I've also seen people, I think in the main Zone.js file you can also say what kind of APIs Zone.js should monkey patch. So you can limit that. So for example, that it doesn't monkey patch some scroll events or whatever, so that it doesn't run change detection too often. Often this results from third-party advertising, marketing, or analytics scripts being initialized in a way that runs there many timers or other interactions in the Angular zone. Yeah, in the worst case, we've seen applications which do over 1,000 plus change detections at startup. Imagine that. That's crazy. Yeah, it's always possible to write code with performance problems, but Zone.js makes it easy to do so. Many developers today use state management pattern or libraries that architect their data in a way where they can tell Angular exactly what changed. Yeah, so on push. So we are already using all those optimizations to have more fine-grained change detection. So I think that's the perfect direction, and this is the direction that they should go. So this was the first part of the RFC. This was quite a lot, but I think it's also the biggest part. So let's now go to the second part. Or let's quickly grab something to drink before we go to the second part, where we have the Signals API. So I will quickly grab something to drink and I will be right back. Okay, so Signals API. A signal is a value with explicit change schematics. In Angular, signal is represented by a zero-argument getter function returning the current signal value. So yeah, that's basically when we have to call the signal, it calls a getter. Signals are read-only. So there are two kinds of signals. Generally, signals are read-only, but we also have writable signals. Yeah, the getter function is used to access the current value and record signal read in reactive context. Yeah, as this is an essential operation that builds the reactive dependency graph. Okay, and then we also have writable signals. So we already saw those methods. We can use set to set a new value. And then we have two functions, update and mutate. I think those are actually syntactic sugar because we could all represent everything with set. But update is like a handy function where you get a callback with the current value of the signal. And then you do like, you return the new value of the signal. Mutate, you get a reference to the signal. So if you have a signal of an array, you get a reference to the array and you can, for example, push something into this array. But I think generally you should use update, but let's see what they write here. The current value by mutating it in place. Useful for making internal changes to the signal's value without changing its identity. Yeah. Depends if you want to go with a immutable approach or not. So use example counter set, so we can set a new value, update current value, we can increment the current value. So again, with update we get access to the current state. In the current proposal, the primary interface is named signal. This represents a read-only value that changed over time. We've chosen this name as it's short, discoverable, and we're expecting it to be the most commonly imported and used interface. Writable signals are somewhat specialized, and adding writable to the name indicates that additional operations are permitted. Yeah. An alternate naming that they consider is read-only signal and signal. So yeah, this aligns nicely with the TypeScript naming schema. I also like it more that signal is just the default, which is readable only, and writable signal. But yeah. So we have another discussion point in here. Give the trade-offs outlined here. Would you prefer the signal writable signal naming pair or read-only signal one? I think I prefer this one, signal and writable signal. I think so, but yeah. Equality isn't interesting. Change. The default equality function compares primitive values, number strings, etc. using the free equal signs, but treats objects and arrays as always unequal. So let's see. I don't know why this should probably be muted. I think this should be muted, even without using immutable data. See. I mean, it can also be update. So yeah, you can update signals even with immutable data. So set is the fundamental operation, update is a convenience method. Yeah, so we have counter, update, but it's actually only syntactic sugar over this. So internal it's actually this counter set. So you actually only need set, but this is just some syntactic sugar that they give you, which is nice. Mutate is for changing values in place. The mutate method will always send change notifications, bypassing the custom equality checks on this signal level. Okay, this is important. So it will bypass the equality check and just always send updates. The combination of the mutate method and the default equality function makes it possible to work with both mutable and immutable data in signals. So it works with both. Okay. In some systems, reactive state is inherently mutable throughout the application. What do you think about our choice to separate readers and writers and the architectural benefits? I think it's good. I think it's nice that you have like readable signals and writable signals. I think that's good. So in the Angular chosen implementation, the signal is represented by a getter function. Some advantages: it's a built-in JavaScript construct which makes signals read consistent between TypeScript code and template expressions. Yeah, it clearly indicates that the primary operation of a signal is read. It clearly indicates that something more than a plain property access is occurring. It is syntactically very lightweight, which we feel is important because reading signals is an extremely common operation. I like it, but the only thing that I've seen that people are then confused, and I mean, over the years we've learned that we should not call functions in the template, and now with signals this is the case. I don't think it's like it's a bad thing, or how to say, but because with signals this is not a problem if you call it, but I think we are just trained to not do that. This will feel weird in the beginning. Yeah, function calls and templates. So this is something that maybe some people could be like, okay, we just call the stuff in the template, and then suddenly you are in a zone-based component and you call things because you're just used to calling stuff in the template. Yeah, but let's see what they say on this. Function calls and template. Angular developers have learned over the years to be wary of calling functions from templates. Yes. This advice arose because of the way change detection runs frequently for components and the potential for functions to easily hide computationally expensive logic. These concerns don't apply to signal getter functions, which are efficient accessors that do minimal computational work. Calling signal getters repeatedly and frequently is not an issue. However, using function calls or signal reads might initially confuse developers who are used to avoiding function calls in templates. Yeah, that's true. TypeScript can narrow the type of expressions within conditionals, even if username is nullable. Okay. However, TypeScript doesn't narrow function call returns. Yeah. Yeah, exactly. For this simple example, it's straightforward to extract username to a constant outside of the if. Okay. Yeah. So those are then some drawbacks. But yeah, generally, I think it's fine to extract this into a constant, right? I think that's perfectly fine. We did consider different approaches and discarded them for the reasons listed below. Now I'm curious, because this is something that I think Quick does. They use dot value, but wasn't chosen for the following reason. It looks writable, even though for many signals it may not be. That's true. It looks like a plain property access. Also true. It is more verbose than when chaining multiple signals together. Yes. Yes, I agree with all those points. I agree with all of them. Initially I was also like, why not dot value? Why do we have to call it? That's weird. But now that I've used it a bit, I have to say that I like it. I prefer this over writing this. I really have to say. As dot value is plain property access, it does not suffer from the same type narrowing limitations that getter functions do. That's true. Yeah, that's a discussion point. We will see it today on the live stream, what people think about this. So far I have to say I'm really on board with the changes that they made. I like it. So, decorators at Signal, I'm not sure. I prefer to have it as a type then, and not like as a decorator. I prefer it. Also, yeah, I prefer the other one. But let's see what they say here. We've explored this option and discarded it for the following reasons. We can only decorate classes and their members, while we want to have signals usable in all places where JavaScript expressions are allowed. Also, it would limit our ability to further expand the way components can be authored. It would be impossible to pass signal instances around. Decorator specification is changing, so it wasn't clear if we could build on it, on the legacy or the new decorator specification. So there's a new decorator specification coming up in JavaScript. It's already there in TypeScript 5. If you haven't seen it, I just recently wrote about it. AngularExperts.io blog, and you will see TypeScript 5 decorators. Here you can read everything about the new decorator specification. It looks pretty cool. So just a small side note. We would have to generate code for the decorated class members that would make the whole library more magical and Angular specific. Getter setter tuple. So that's basically, I think that's what the, who does that? React, Svelte. React is something similar with state, I think. I also don't like that too much, because then I have to do this all the time, so we can use destructure assignments when defining properties in JavaScript classes, so yeah, then it's anyway off the table. But I anyway prefer the one they have. Computed signals. So yeah, computed signals is the idea that you have a signal. So you have a computed signal, and inside there you pass a callback, and in this callback you access signals, and whenever, for example, counter changes, then our computed signal relearns and is recomputed. Same for color. I think computed signals are pretty great. So let's go a bit forward here. Here, the algorithm choosing to implement the compute functionality makes strong guarantees about the timing. Computations are lazy. The computation function is not invoked unless someone is interested in its value. So if you never read color, this will never get called. That's good. I think effects, for example, are not lazy. They are eager, actually. Computations are disposed of automatically. As soon as the computed signal reference is out of scope, it is automatically eligible for garbage collection. Okay, that's great. Not explicitly clean up boundaries, and our operations are exposed by the library. Computations are glitch-free. It's guaranteed that a given computation is executed a minimal number of times in response to dependencies change. The computation never executes with intermediate dependency values and is immune to the famous diamond dependency problem. Okay, that's pretty cool. Greetings will always be recomputed if the showname signal changes, yes. So if this changes, then this will be recomputed. But if showname is false, the name signal is not a dependency of the greeting and will not cause it to recompute. So that's great, because we use the eternity operator here, and that's pretty awesome. Now, effects. An effect is a side effectful operation which reads the value of 0 or more signal, and it's automatically scheduled to be rerun whenever any of the signal changes. So let's say we have an effect when first name or last name changes, this effect will rerun. So yeah, the use cases are synchronizing data between multiple independent models, triggering network requests, performing rendering actions. Effect functions can optionally rerun and cleanup function. If returned, such cleanup function will be executed before the next effect run. The cleanup function makes it possible to cancel any work that the previous effect run might have started. Okay, so you can have you can return a cleanup function where you can clear an interval, for example. I was not aware of this. That's cool. I think it's great. Given the variety of effect use case, there is a wide spectrum of possible execution timings. This is why the actual effect execution timing is not guaranteed, and Angular might choose different strategies. Application developers should not depend on any observed execution timing. The only thing that can be guaranteed is that effects will execute at least once. Okay. Effects will execute in response to their dependencies changes at some point in the future, and effects will execute minimal number of times. If an effect depends on multiple signals and several of them change at once, only one effect execution will be scheduled. Okay. I think my friend Thomas is working on a blog post that will illustrate this behavior. He showed it to me yesterday in a Stack Blitz. So this will soon appear on our blog here on AngularExperts.io. If you don't want to miss it, of course, you can go ahead and either follow him on Twitter, or you can subscribe to our newsletter here if you want that. I think he will publish a blog post that will illustrate this behavior. Stopping effects. Yeah, you can also, by default, Angular effects lifespan is linked to the underlying destroy ref in the framework. In other words, effects will try to inject the current destroy ref instance and add registered stop function in there. For situations where more control over lifespan scope is required, one can optionally pass the manual cleanup option. Okay, so you can manually clean up an effect. Okay, if this option is set, the effect won't be automatically destroyed, even if the component directive which created it is destroyed. Effects can be explicitly stopped destroyed by using the effect ref instance returned from the effect creation function. Okay, so you get a reference and you can destroy it later on. We generally consider that writing to signals from effects can lead to unexpected behavior, yes, and hard to follow data flow. As such, any attempt of writing to a signal from an effect will be reported as an error and blocked. Okay, so you cannot do this. Okay, you can say allow signal writes through, and then you can do it, but by default it will be an error, which I think is good. So yeah, you can create signals outside of component stores. Any guidelines when it comes to granularity of signals? So that's also something that I'm curious about. This is a common question. Given a non-trivial object, it is not obvious how many signals should be created. One signal for the entire object, or maybe one signal for each individual property. Currently, we can provide hard and fast rules here, but would suggest starting with more coarse-grained objects, one signal for the entire object, and split up if necessary. While it is tempting to go with many fine-grained signals, it's often not practical. Creating all those signals can get verbose and counterintuitively not that performant. Okay, so creating and maintaining signals has its cost. So we would go with like one signal. So yes, I think, will you publish the library? Okay, so that's more like if they want to publish the signals as a separate library. I think for us it's more important now to have a look at signal-based components, because that's something that we will really use. So what is going on here? We've already spoken a bit about signal-based, especially when we talked about change detection and getting rid of zone.js. So the idea is that you have like signal-based components, and signal-based components have fine-grained change detection. But to have a signal-based component, you need to set signals true on the component level. So in the component decorator, you would set signals to true. So when you set this, you control a number of framework behaviors outlined in the rest of this document. So signals false, we now speak of zone-based components, and signal true are signal components. And we can use both, as we said. Signal-based components cannot extend zone-based components, or the other way around. I generally think that you should not extend components in Angular. There are very few cases where I see a benefit of this. Yeah, we know setting both signals true and standalone true is kind of boilerplatey. We're still thinking of ways to make this more concise, yeah. So I'm curious what they will come up with, because this is boilerplate, yes. Let's take a look at a counter component that uses signals. Signals true. We have a count. This is a writable signal. Counted update, yeah. And this would now have like fine-grained, so view-based change detection, because we have signals true. Yeah, that's what we already discussed. Could Angular automatically unwrap signal values? So the question is if we really have to call it, or if we could just write like count, because here now we have to call it. If we could just leave the brackets away. So Angular cannot automatically unwrap signal values like this for a couple of reasons. A component may want to bind or accept the signal as a value rather than always reading a signal's contained value. Angular compiles templates to JavaScript code at compile time. However, the tracking mechanism inside signals operates entirely at runtime. Okay. Yeah, so they cannot really have that. So we need to call it, which I think I'm fine with that. Let's look at an example that mixes use of signal and non-signal values in a template. So I think there is a problem now with this, since it's view-based. So what's happening, if you have this signal and it gets updated, and if somehow, I think that's also something, they will probably also explain that here, but if somehow this name changes, it will also get updated, because it will just be view-based checked. So Angular, the change detection still works the same, it's still like the dirty checking, but it's only like, it's more fine-grained, it's only on this view, but if the name changes, it will still get updated, so just be aware of that. Yeah, Angular would update both values. Yeah, I think it's exactly what they describe here. So we have some ideas on how to help guard against this behavior. Raise an error at runtime if a template expression changes without depending on a signal read. Raise a compile time warning or error via the Angular language service. Yeah, I don't know what is better. A runtime error is... I don't know, I would want to have a compile time warning or error. Probably an error, because warnings are often ignored. That would be cool. But then if I really want this somehow, I should also be able to somehow say, okay, this is intended. which I don't think it should be. No, I think a compile time error would be great. If you bind to non-signal value that is not read-only, yeah, this would be cool. I'm not so fan of the runtime error because I don't really see it, and maybe I develop my page, compile it, everything works, and then at runtime you only get it when you navigate to the page. So yeah, I would be like in favor of the second option. You can define computer properties similar to how you define writable signal. That shows Fahrenheit. Yeah. Pure pipes and templates. Computer properties can simplify your code and reduce. Yeah. So it can replace manual updates in lifecycle hooks, function calls, and template expression or pure pipe. I like that. Signal-based inputs. In signal-based components, all component inputs are signal. Let's look at an example of declaring some signal-based inputs. So remember, that's basically the same as writing add input. So when we speak of inputs, we speak of the component inputs, not as inputs in terms of text or input fields, really a component input. And we now have input string, so this would be a input signal and with a default value. I think you can then also, because now Angular has required inputs, I think if you don't have a default, then you need to have the required, I would say, because signals need to have an additional value, right? Create an input with options, alias disabled. Okay. Yeah, here the input function replaces the add input decorator. 2 parameter initial value, similar to signal, and an options object. Read-only signal. So they are read-only. That's something important. So you could not go and say first name.set. But I think they also have a concept for that. To a consumer of the component, signal-based inputs are indistinguishable from non-signal inputs. One thing that now comes to mind is if I do signal, so they were speaking about writable signals. If I do signal, this basically is writable, right? Or no, this is readable. But I could do Celsius.update. So maybe it would be cooler to have like the default signal writable. Yeah. I think this was a discussion point on the first one. I should write that down. So what I'm thinking is, like, if I understood it correctly, we were speaking about writable and readable signals, right? And the idea, I don't know where it was. Maybe it was here. I will comment in here on this thing, because the idea is that we have by default signals are readable, but then this, so the idea was, do we speak of signal and writable signal, or of signal and read-only signal or something? But if you create a signal, then this is writable by default, because we can do like Celsius.set.update. And I think then it kind of is the contrary of the proposed things, but let's see what they say. Signal-based inputs. Yeah, now model inputs. So signal-based components additionally have access to a new type, model inputs. And with model inputs, it's basically a writable signal. So you could then also write to this. So you could then check that update. So you could call update set mutate on this. You cannot do this on the input one because the input one is read only. So let's see. So we have some page, some checkbox checked, and then some page. So we would have some checkbox and checked is admin. Checked is the model that we pass in. Note that the getter is not called here. The raw signal is passed. Yeah, so here we only pass the signal, we don't call it. The model function defines a specific kind of input established. Yeah, you basically have a contract between the client and the parent if you want to have a writable signal or not. So you are explicitly opting into the contract that the child component can write values into your signal. Yeah. One-way binding behavior. You can create one-way bindings on model inputs, just like standard input modifying. So if you would have the checked is admin, even if this is a writable, so the sum checkbox component internally is like a model, right? It's not input, it's model, so it's a writable signal. But if you only pass it like this, then it's one-way binding. Yeah, the value it writes will not propagate back to the parent. So if some checkbox alters is admin, it will not propagate back, but it would if you would remove this. Okay. So this matches the current behavior of Angular inputs. This RFC uses Angular existing banana in the box syntax for two-way bindings. This syntax originally came about as shorthand for both property binding and event binding. Yeah, so we have the banana in the box, which was basically short for value change, because it's basically an input and this also reacts on a change event. The value propagates back up when the component sets a value in the model property. Because of this, it might make sense to use alternate syntax for two-way binding in signal-based components. Should signal-based components introduce a new syntax for two-way bindings? I'm not sure about that. I think this illustrates to Angular developers that it's two-way binding. I kind of like it, even though this is not really fully accurate anymore for signals. Not fully sure on that one. So in signal-based components, inputs are read-only inside the component that receives them. So this is a departure from Angular's current approach, where inputs are mutable everywhere. Making inputs read-only will lead to cleaner, easier to follow code. Yeah. I mean, if you want to have the other one, you can still use model when adapting existing Angular components. Yeah, model provides a way to preserve the original behavior. I think that's good, as long as you still have the backwards compatible way. I like this. Inputs take an options object which allows specifying the initial value of the input when not bound, the alias, whether the input is required, etc. Initial value alias current user. Okay. Yeah, so you can also have this required flag. That's a flag that we usually get for the traditional inputs. So we can also use that. Primitive values, Boolean number string. There's an alternate syntax available which uses the first argument for the initial value, is logged in input, is all powerful. So yeah, you can alias it as is admin. You can either use the initial value like this, or you can use it as initial value true. I actually prefer this one. I prefer this syntax over this one, because this kind of indicates that initial value is also optional. Here it's kind of clear. I have a required initial value and then an optional config object. Yeah, okay, decorators we've already seen. Angular queries include the APIs view child, content child view. Yeah. Okay, and Angular queries include the APIs. View child, yeah. In a signal-based components, all queries produce signals. Let's look at an example of declaring some signal-based queries. View children, so that will be a signal of the field icon array, and because we get access to this, to multiple of them. View child is an element ref of field, so it's a signal of an element ref. Okay, I'm good with that. Makes sense. Yes, query list API. Gone. It's just an array. I like that. I like that. I think that's easier to work with. You get an array of field icon. You don't get like a query list. I think that's better. Output signals. So in signal components you have output. It's still a event emitter. It's not a signal. It's still an event emitter. The API is pretty much the same. It's just different how you declare it. Yeah, then component lifecycle and defects. So that's an interesting one, because you will get new lifecycles. So you will get a after init. The special thing is also that they are not class methods. They are just methods that you either call inside your constructor, or you do it like you can assign it here and then call it somewhere. But basically, inside your constructor, when all inputs have their initial values, effects we've already seen, so that will probably replace on changes. After the DOM of, so we have an after render, after the DOM of all components has been successfully rendered. After next render, same as after render, but only runs once. So here I have to be honest, I am not sure. I've also in a document added this question. I'm not sure in which use case this can run multiple times. So that I don't get yet, but let's see, maybe somebody has added it in the comment. So after next render, same as after render, yeah. After render effects, so basically this is a way to run effects when the render is done. So when all components have rendered, you can then run an effect, but it's only running if the first name, for example, changes. It's basically like effect, but you only run it after the DOM has been updated. And before destroy is like ng destroyed. It needs a bit time to write them here inside the constructor, which feels a bit weird. But I think it's just because I'm used to write them differently. Yeah, many cases that previously relied on ng init and ng change should instead use computed after init and effect. For situations where you need to perform some imperative operation, after init and effect, yeah. Okay. Rendering. Brand new to signal-based are APIs that let you run code after DOM has been updated. Yeah. This one, callbacks run every time the DOM has been updated. Okay. For all of these API, the DOM in question is not tied to the component in which the callback is registered. Instead, the callbacks run based on when any DOM has been updated by Angular. Destruction before destroy callbacks work identically to the ng and destroy methods. Yeah. Why not class methods? So class methods can only be implemented once, that's true. Grouping multiple effects into the same method would cause them all to run whenever their signals change. Yeah, so they have an opportunity to design that will be more flexible. Yeah, this is important. So now they take the chance to maybe in the future also have like function-based components or something. So they are no longer limited to the class API actually. Decorators, we've already seen this. Yeah, we find this API unappealing because it introduces more boilerplate for declaring inputs. I agree. So yeah, the only thing that I want to ask here so far is especially they say signals is read only by default, but then if we declare a signal, we just do signal and not a read only signal. So special function signal based APIs, yeah. Today Angular processes decorators like input at compile time. Your runtime JavaScript bundle does not actually include any decorators. The new signal-based function APIs behave the same way. Angular will process input, output, util at compile time to statically understand the declarations. This means that you can't use the APIs as typical functions throughout your code. For example, you cannot create a custom boolean flag that calls input. Yeah, which is good. Why not change detection strategy? Signals, as we've seen, it's not just signals is not just change detection, it's input, outputs, it's like a bunch of other things that it affects. So I think there is a broader change to signal components than just change detection. It's more. So yeah, that's basically the second part. So let's go to the last part and then we are actually through. Then we have a pretty good overview of what is coming. So the last thing is basically the interpolation with RxJS. So sometimes, as we've seen with this GitHub user search, sometimes you want to use observables, sometimes you want to have like a signal as an input, you want to convert it to observables to get all the RxJS powers, to use all the operator functions on it. So yeah, so we have from observable, which converts a signal to an observable, which converts a observable to a signal. Now, so you use from observable, you pass in your stream. The from observable internally subscribes to the given observable and updates the return signal. So for anybody that is interested, like for sure the Angular implementation will be a bit more complicated, but if you are interested how something like this could look like in a simplified version, you can look at this link here on my GitHub user search. I have this under source app Rx interop, and you can see from observable how we did the from observable, where we converted an observable to a signal. So we did it with initial value. I don't know if they will have it, we will see it in the RFC, but basically inside here you subscribe with your observer to the source observable, and basically inside the observer you just set a new value on the signal, which you then finally return, and you use some other stuff like the destroy ref to clean up your signal, your observable. Where were we? And we also have the same to go the other way to observable, which is easier. So there you just run an effect and you return the signal value. So again, those are simplified versions. So for sure, the original version of Angular will be more complicated. So initial value, that's what I wanted to see. Observable can be used to model both synchronous and asynchronous data flow. However, they don't distinguish these two cases in their API. So any observable might be synchronous or it might be asynchronous, right? Signals, on the other hand, are always synchronous. The signature of the fromObservable function will allow you to pass a default value to use if the observable has not emitted by the time signal is read. So yeah, fromObservable, okay. You see, you can also have this initial function, it's the initial value here, which is great. For the cases where this default value is not provided, we need a strategy to handle the case when the signal is read before the observable emits a value. So how do they do this? Throw an error on creation. Yeah. If we do not get a value, that's something they could do. fromObservable. Throw an error on a read. I think that would be better. Throw an error on read and not initially. But then you might also come into like some weird timing. What if you read a value based on some user interaction and yeah, you perform a backend request, and sometimes it will work, sometimes it doesn't work, because like sometimes you will read it after the backend request, sometimes maybe before, I don't know. Like maybe this is not the best. Use a default initial value such as undefined if. Yeah, I think that's valuable. But then again, you have to handle the async, the undefined value. But I think that's fine. The nullable type is annoying. Yeah, you wouldn't be able to tell whether fromObservable value change is actually a null value or just hasn't been emitted. Yeah, we're undecided on the best default behavior for fromObservable, but we're learning towards the option with the least fraction, option 2, over the most safe, option 3. Yeah, so option 2 was the one that I don't like so much. But let's see, it's still an open discussion, like maybe we should write it down for today's stream. Initial value. Or maybe also for the discussion. Maybe we can then also do like a reproduction example for this. Error and completion states, which is capable. An observable has 3 types of notifications. When an observer subscribes to it, next error and complete. When the observer created from observer is notified of an error, it will throw this error the next time the signal is read. This error can be handled the same way any other error coming from a signal would be. Okay, yeah. So you can try catch that. The error can be transformed either on the observable side or on the signal side. So you can have from observable and you can transform it here, or you can do it here inside try catch. I don't know what you prefer, doesn't really matter. So signals don't have a concept of being complete. When an observable is complete, the observer created by fromObservable, so that's the internal observer, right? That's basically what we see here in my, again, simplified, but you have an internal observer which you pass in. We'll simply not receive new values from the stream. We acknowledge that the completion state does not have meaning for an observable, and sometimes you might care about this, even with it not being surfaced directly in the term return. So basically you have a signal, and if the observable completes, like you don't get any notification about this. But you can represent this signal from observable. So you can say finalize is complete set true, and you can represent this. But yeah, what are the cases where you need this? So from signal allows you to convert a signal to a observable. Yeah, That's pretty much straightforward. You pass in a signal and you get back observables. When from signal observable is subscribed, it creates an effect to monitor the signal, which exists until the subscriber unsubscribes. So that's something we probably didn't do like in my implementation, right? We just created the effect, but we didn't clean up that effect because, as I learned today, going through that RFC, you can have an effect ref, and then when the observable is completed, you could run that. Yeah. Which exists until that subscriber unsubscribed. This differs from observable, which automatically cleans up its subscription when the component is destroyed. So this really lives until the subscriber unsubscribed. We believe it would be incorrect from signal to tie the resulting to the observable to the life cycle. Okay, for two reasons. I'm curious now why. The incoming signal might itself not have the same life cycle as the component. Signals are valid as long as anyone still has reference and the signal may have been passed in. Yeah, it can be that you pass in a signal like via input. The observable might be used in other external RxJS computations, such as being passed into a switch map. Moreover, it would be passed into a service and persisted. Finally, observable unsubscriptions might have side effects, and the user should control when those run as with other observable. Okay. If desired, you can tie it manually, so you can still do like this. From signals and then take until destroy. Okay, but this is an important point to know. The observable produced by from signal uses an effect to send the next value. However, because effects are by nature asynchronous, the observable emission will be asynchronous, even for the first value. Okay, therefore all values emitted by from signal observable are delivered asynchronously. This has some interesting consequences. Consider setting a signal several times in a row, which is an asynchronous operation. So you do from signal, and then on my signal you set 1, 2, 3. So the observable will only ever produce the value 3 because the signal is set synchronously. Okay, but this is then an asynchronous operation, so probably it's handled in the next tick. So it's different from behavior subject. In other words, yeah, signals are not streams. But what if the signal updates before the effect is scheduled for the first time? If you want to get the first value synchronously, you can straightforwardly implement this behavior as so. Yeah, okay. One effect for all observers with share replay. If you expect to have many subscribers and observable produced from a signal, you might want to use share replay operator. This helps you avoid creating a new effect for each subscriber. Yeah. So the ref count you use so that the underlying effect is cleaned up after all users unsubscribe. The buffer size 1 because we only care about caching the latest value. So why not doing this inside inconsistent behavior, code size? Yeah. The first subscriber. So basically I would have to do share replay for everyone, so you don't have any control over this. It's easy to implement and low overhead. Okay. Angular users often want to complete a stream when a related subject completes. The following pattern is quite common. So yeah, I don't think that this is so common. Like, yeah, it is common. So usually you don't do HTTP inside your component, therefore I thought it's not so common because this usually happens in a service, right? But generally, yeah, you have a stream and then you do take until this destroyed, and you have to destroy its subject. I never do a replay subject, I just do a subject. But yeah, we are introducing a new RxJS operator called take until destroyed, which simplifies. Oh, that's nice, because they now have the destroy ref. So then you basically don't have to do the lifecycle hook. I think that's cool, because they will inject the current cleanup context. So I think that's again something that is similar. The way that they can do this now, they now have this destroy ref, so they can inject the destroy ref, call on destroy, and then basically create the subject themselves. So that's, I think that's pretty neat, and that's actually already everything that we have for the RFC. So we are through. This was quite a lot, and there's quite a big change coming to Angular, but I think it's cool. I think it's cool. It's also backwards compatible, so no need that you go and rewrite the whole application, but it's an important step for the future of Angular. So let me quickly also see if I can find this this one point that I have to just clarify. Writable signals. I think it was on Signals API actually. I think it was on the second one. A signal is a value. There was some discussion point about this. Yeah, in the current proposal, the primary interface is named signal. This represents a read-only value changing over time. We've chosen this name as it's short, discoverable, so that's the interface name. Writable signals are somewhat specialized. Yeah, that's good, but if I create like a signal, given the trade-offs, so they were discussing if signal, writable signal, or read-only signal and signal. And I was initially for that, but the thing is, if you create a signal, like, I think I have an example. Fun with signals, was it this one? Nope. So basically I just want my input example. I was not fun with, that's the wrong repository actually. It was this Signalo. Yeah, so there I have a counter component. So basically what I'm thinking is, okay, the interface is called signal, which is a read-only signal. But let's say simple counter. But then what you do is you create a signal, and then you can still do count.set, which is basically a writable signal. And yeah, the interface is called signal, but here we also call it signal. I think it would align more if we actually speak of signal as writable and read-only signal, now that I see this. But let's see, that's something to add. I will add a point here. So, okay, let's see. I will then later add, after the stream, I will add this description there. Okay, so we are through. Thanks everybody for joining. I am curious also, let me know what you think of this. Also, today, don't forget it, there is Angular Signals RFC discussions with the Angular team. It's this link, I will post it in the chat. Don't forget to join that. That's basically where we go, where the Angular team will be available. It's in 8 hours. Yeah, make sure to join there. Give a thumbs up. So yeah, hope to see you there. And then I now have to go to work. So I wish everybody a very nice day and thanks again for joining. See you!
I'm infatuated, I'm obsessed, you a flex, I'ma make you mine. You serving power and you sexy, give you all my time. You the only thing I see, I give you all of me. Just to get you, I've been wanting you for so long. And to be honest, you the only one that make me smile. Like, oh my wow, you so bad and you make me laugh. You so supportive, I remember how it was before you. No, I can't lie, I was barely getting by.